And welcome to the content-rich environment. We got lots of stuff to cover today, folks, so this one might be a little lengthy. Please stay tuned as there's a lot of stuff to cover. Giant filament in the southeast. Looking here at the 304 angstrom view. And here's the view from 171 angstroms. Still seeing that filament down there. Something to keep an eye on throughout the day. North Pole coronal hole looking very defined, and some diffuse coronal holes in the Earth-facing region. Here's an ultra-high-res image of that. And you see that very large system there associated with the South Pole. I'm trying to shrink her down here. And let's move on and look at more info. Here's the Enlil loops. And this is the prediction of obviously what's going to happen at Earth in terms of density and velocity of the solar wind, as well as at stereo A and stereo B. Some wild perturbations out there at stereo B, perhaps that coronal mass ejection. Although it's looking a little late for that. I'm not exactly sure where this prediction's coming from. In any case, look at the real-time solar wind. And there you see some recent shifts in the BTBZ as well as the phi angle. Solar wind density 3.10 protons per cubic centimeter. And solar wind speed just recently ramped up to 376. So we see some wavy action there. And the ACE data is looking corroborative. Here's the magnetosphere movie, and the magnetosphere is looking super weak. Solar minimum conditions persist, folks. 10.7 centimeter radial flux went back down to 67, down to 66, and I think it's back at 67 now, but solar minimum conditions. Anyway, there's 4 hours of the magnetosphere movies, courtesy University of Michigan geospace model. And it's steady as she goes as far as ground magnetic perturbations also. Not good news for those folks in earthquake-prone zones as far as solar activity, because there's a coronal hole right in the Earth-facing zone. So please be prepared, as we have a massive magnitude 6 and 7 earthquake drought. Anyway, there's the delta B changes in the Earth's B field. Nothing to write home about there. Again, 10.7 centimeter radial flux down below this orange line, which I've drawn in at 70 solar flux units. And the GOES magnetometer's got some significant spikes in it here. No explanation for that, folks. Not really represented in the solar wind. Anyway, there's the data from GOES magnetometer, 14 and 15. Here's the Gong 2 data. And perhaps we've entered into this North Pole polarity region early. This data, an hour 29 minutes old, that would explain the GOES magnetometer spikes. Perhaps a fleeting magnetic connection with the North Pole oriented portion of the current sheet here depicted in green. And that could snap across more quickly than you expect based on activity going on at the equator and at the poles and every place else. Keep in mind, magnetic things can change with absolutely no warning or indication. And here's the GOES electron flux. We see a bit of a dip as if we got some solar wind coming in there. Bit of an uncharacteristic electron flux dip. And we saw a decrease in the greater than 2 mega electron volt electron fluence. Surface charging hazards are minor, mainly north of the equator there around Central America. X-ray flux totally flatlined. And the KP has been at 2 for the last 12 hours, up from 0. And here's the ionosphere map, 6 hours of it, courtesy Government of Australia, Bureau of Meteorology. And things are looking pretty normal there. Let's bring up the latest image. Nothing really to write home about there, folks. Are you aware of the ICON mission? NASA's ICON, Ionospheric Connection mission? It just launched. Here's a tidbit. I think it's a tidbit.
ICON's task is to help us understand just what causes the constant changes we see in the ionosphere.
Anyway, we've left links to the article here from Extreme Tech. The mission was delayed due to, is it Lockheed? Northrop Grumman's Pegasus XL rocket system. This got launched from a plane anyway. It's up there now. And we may have additional ionosphere data. And for that, we thank you. Let's look at the earthquake rundown, speaking of the ionosphere. And about 24 hours ago, we see a 5.1 magnitude quake at Vanuatu. And this video, if you're wondering, was shot at 4:57 a.m. is the current time. And that's Eastern Daylight Time. I'm located in Lehigh Valley, Pennsylvania, if you're wondering. And thanks new viewers and patrons and so on. Next on the list, occurring around noontime UTC, that's Universal Time Code, a 4.5 at Sicily, at Italy. And yeah, little uptick in seismic activity around there. Here's a 4.4 at Alaska, 4.4 at a different part of Alaska. Those two quakes occurring only about 20 minutes apart, folks. And then about an hour and 40 minutes later, we see a 4.9 way down south in the South at Sandwich Islands there, near the Antarctican plate. Next, a 4.4 at Georgia, and we don't mean the state of Georgia, we mean the country of Georgia. Please leave a comment if you're viewing from the country of Georgia. Somehow I doubt it. How about a 4.7 at Papua New Guinea? This one coming in at 1537 UTC. 4.2 at Kodiak, Alaska. The magnitude 6 and 7 earthquake drought continues, folks. I mean, we're seeing a ridiculously low number of quakes right now. Another quake at California. Let's check out the location of that one. Why click it once when you can click it multiple times to get the same result? Anyway, there's a location of that one. Shout out David Schlottower. Did you feel that quake also? I think that one's too far south for you there. Anyway, there's a location of that. Located in the Galabon Range. I never heard of it. Did you? Please leave a comment if you heard of the Galabon Range. All right, back to the list here. Here's one near Panama there, south of Panama, 5.1 magnitude. That one coming in at 1956 UTC yesterday. Here's a 4.5 at Japan. 4.9 at Indonesia. 4.7 at Indonesia. Looks like a lack of deep quakes also, folks. No deep quakes, no large quakes. 6 and 7 magnitude earthquake drought continues. It's weird. It's kind of creepy. And please know which buildings may fall down if you're in a quake-prone zone. Last on the list is a 4.6 in Indonesia. That one coming in like an hour before we recorded this episode. Here's the pressure maps on windy.com. We'll let that advance about one day. As rain descends upon eastern Pennsylvania. We'll let that get to about midday Universal Time tomorrow. And there's where pressure systems are expected to be according to windy.com's GFS models. Here's the volcano rundown. An uptick at Mount Etna. Check it out, a 15,000-foot ash plume there. So seismic and volcanic activity kicking off at Italy. Mount Shiveluch also exploding. Uptick there. 25,000-foot ash plume's been created. Mount Aso, activity continues. 7,000-foot plume there. Sakurajima exploded, produced a 9,000-foot plume. Tokono, continuous emissions, explosive activity, 8,000-foot plume. Popocatépetl, new emissions there. Nevados del Ruiz, some seismic activity located there. Down in Colombia, Revenador, explosive activity there. 15,000-foot ash plume. Mount Sabancaya exploding, 21,000-foot ash plume. Copahu, unable to detect there, probably satellite images, covered by clouds. Nevados de Chilean exploding, producing a 15,000-foot ash plume. Please don't pole vault over Nevados de Chilean. We don't want to lose a viewer. Here's where stuff is in the solar system. And don't get bored, folks. Milky Way Galaxy team for the win, as this video is going to keep getting better. There's where stuff will be in 1 week. Here's where stuff is above my head, courtesy of in-the-sky.org. It's 5:02. Do you know where your Deneb is? And here's the real-time lightning map. We see some lightning in the Pacific, the Atlantic, the Caribbean, around Lake Erie. And I believe the heaviest is actually in Texas, as they get hammered once again. Doesn't look too bad. There is the weather underground. Welcome to the value-added services section of the video, folks. There's the U.S. Doppler radar. We're not going to zoom in. Although, here is the U.S. water vapor map. If you were wondering what your weather was going to do, break out the U.S. water vapor map. Just do a search for NASA GOES interactive weather satellite. And it looks like some heavy moisture descending down into western Montana again. Let's take a look at that zone. We got moisture traveling from north to south, undoubtedly right along a ridgeline there in the Rocky Mountains. And let's take a look at one more area here. It's the convergence zone over Indiana. You want to talk about some serious flight turbulence going on. Really cold air hitting really average warm air. And you can see this dry air is being forced to rotate counterclockwise here. Dry mass of air typically wants to rotate clockwise and be part of anticyclones and so on. Anyway, there's that scenario. If you're flying across those areas, expect some turbulence, to say the least. Here are the jet streams of the Western world. And I just missed 1337. It's 1337. Do you know where your YouTube video is? And here's the Eastern jets. And let's move on to the that is censored, that is a sinkhole, where algorithms don't screw us over. Have you watched our smAsho movie reviews / referrals, where we talk about Exorcist 3 and The Fanatic and 9 Lives and even El Camino, a Breaking Bad movie? Oh yeah. Here's a clip. Hi, you've caught me trying to not have a heart attack while watching Exorcist 3. Here's another clip. Flat, and see the horrified look on this young girl's face? See that? That's the same look that's going to be on your face throughout this movie. Seriously though, watch the review. And after you watch the review, watch this movie 9 Lives. If you want to be horrified, you want to scare the crap out of your friends, family, neighbors, foes, whoever, screen 9 Lives. They really go out of their way to set up a sequel too, and I can't say enough about how troublingly absurd this movie is. Let's talk about stuff that's not scary. CERN. CERN, not scary. Creating high energy reactions. People are afraid that it's going to consume the entire universe and create a black hole, which is a non-existent theoretical piece of math in search of observations. Let's talk about more stuff that's not scary, the electromagnetic spectrum. No, just kidding. Let's talk about some stuff that is scary and a YouTube channel that is fantastic. Data is beautiful. Were you aware? They don't need your subscribership. They've got nearly 300,000. We do, but they don't. So subscribe anyway and check this out. What we're viewing here is the most popular websites from 1996 to 2019. Now, you can see back in July of 1996, AOL was the most popular website with 122 million hits. You want to see something scary? All right. Well, it is October. So, what do you think about that? How about that? Google with 40 billion hits. And I would also note that, let's go all the way to the end. As of October 2019, you'd note that Google and YouTube are the leading websites. Let's look at social media platforms from 2004 to 2019 if you want to be freaked out about that. Data is beautiful, even if it scares the crap out of you. So you're probably wondering who was running the social media show. Well, of course, Facebook took over MySpace and yada, yada, yada. Once again, though, we see major domination in the upper level of this. We see Facebook and Instagram, which are the same company. Facebook bought Instagram like ages ago. And then YouTube, number 2. And then Twitter at distant number 4. Sorry, Twitter. I don't really use the platform, although we are on there. Check it out, smAsho. I mean, twitter.com/smAsho. And we did leave links to both of these videos as well as Data is Beautiful's YouTube page. Shout out Data is Beautiful. It sure is. Even when it scares the crap out of you. Let's talk about some data that's not so beautiful. Phys.org's organization. Now, if you go to phys.org and you click on the Earth section, 9 out of 10 articles are going to feature some kind of osmotic tidbit about global warming, how the planet's warming, yada, yada, yada. Well, look at the headline of this one. Last year's extreme snowfall wiped out breeding of Arctic animals and plants. You would probably be asking yourself, how could they fit some global warming into that? Well, they did. They're going to tell you that it's so hot that it's cold. And that's common theme. It's so hot that it's cold, folks. That's the way climate works. And by the way, I don't know if you know anything about heat latency or not, but have you ever had a doctor check your temperature? Now, he probably used a certain orifice of your body to check your temperature. He probably didn't make you do a breathalyzer to measure your temperature, which is why measuring the Earth's atmosphere is not an accurate measure of the thermal properties of planet Earth. We know less about this planet than we think we do about exoplanets. So anyway, links to this article also. As last year's extreme snowfall wiped out the breeding of Arctic plants and animals, and that's apparently a result of it being so hot that it got very cold, and we had record snowfall in the 2018 to 2019 winter, as well as record-breaking cold temperatures all across the Northern Hemisphere. And if you're wondering what it's like at Greenland, well, we've left links to this also. Polar Portal. And there's the mass balance. We're talking gigatons. And if you look, it's at a pretty low level now. But it's right in the 2010 through 1981 range. So I don't know what all the hubbub is. Greenland is not melting. There's 5 meters of snow from coast to coast all summer this year. If you weren't aware, just head over to windy.com and bring up the snow depth data, and then go look at Greenland. Summer just ended there. And boy, oh my gosh, Greenland is so melted. Now, that study was about northeast Greenland. And geez, oh whiz, sure enough, there is a bunch of snow out in the ocean because there's so much sea ice there at the end of summer. That snow is accumulating on the sea ice. And by the way, this is the way the world glaciates, folks. Snow falls and it doesn't melt. And you end up with more than 5 meters of snow coast to coast on the island of Greenland. Meanwhile, the mainstream media is going to tell you, oh my goodness, Greenland is melting. Sea levels are going to rise. Where's the melting? Where's the gravitational lensing? Where's the science? I think I saw it in a porta-john. And just to reiterate, I don't know what's going on with phys.org. They don't have their articles even organized correctly. They've got astronomy and space articles that don't appear in the astronomy and space section. They've got Earth articles that don't appear in the Earth section. It makes no sense. I mean, check it out for yourself, phys.org. It's a mess. It's full of nonsense. There are some good articles. If you don't have a discerning eye, the level of nonsense will stifle. You'll lose an IQ point. You'll lose 1 IQ point per article if you don't know what you're doing. Over at phys.org. Were you aware that Amelia Earhart's bones may have been found in 1940 and then got misidentified and misplaced in Fiji someplace? Well, we've got links to this article also. They found all kinds of stuff. Everything from a sextant box that could have belonged to Fred Noonan or Navigator, bits of cosmetic bottles, worked aluminum that might have come from the Electra, and a host of other artifacts. The fact that coconut crabs will dismember humans and disarticulate their bones is a major co-founder in any search for skeletal remains. It's possible that the remains on Nikomoro Moro belong to another hapless traveler, but I think somebody's looking into this nowadays. This article from Extreme Tech, also linked below our video. Just like this article here from SciTech Daily, it's an actual picture, not CGI. I don't know what all the hubbub is, as I've been looking at NGC 4380 since the mid-90s, when Hubble first started taking photos. But here's a multi-wavelength view, if you'd like to check it out yourself. Here's an article stating absolutely nothing about cosmology, linked below the video. Let's go to something that is stating something about cosmology. Galaxy Zoo on zooniverse.org, the largest citizen science project in the world. We're going to classify a galaxy. This one's got features. A bulge, if not much else. So check out zooniverse.org's Galaxy Zoo project, as we need humans to classify galaxies. Artificial intelligence is too stupid, frankly, to do this. So just going to go through a quick classification here. I don't see a bar in this particular elliptical galaxy. I don't see any sign of a spiral arm pattern, but I do see a bulge. Please leave a comment if that's what she said. It's a large bulge. Please leave a comment if that's what she said. Is it merging or disturbed? I don't think so. I don't see any rare features. I'm going to say lens or arc, because there's a small irregularity there. And I'm going to also say something else. This is probably an ultra-massive galaxy here, and if we look closer, we may see jets. Dear astronomers, please take an infrared image of this, or perhaps a other radio wavelength image. And if you're wondering which galaxy they're talking about here in this one, it's that small one in the center. Don't classify the stuff around it, and don't freak out about weird visual artifacts, like this two-colored galaxy here in the foreground. And we talk about all kinds of stuff on this channel, like X-ray emitting objects. We're not going to get into the crab or anything, but view our cosmology video from yesterday. We raised some interesting concerns and questions. We are also going to be making a video soon about the Earth's magnetic field and where it's generated from, and how there's no empirical evidence about there being a nickel-iron rotating liquid core that creates the magnetic field, but with rotating iron, and that's just completely conjecture, folks. There are mysteries, to say the least, below your feet. And I would also note that the deepest hole ever dug found a lot of unexpected hydrogen down there. That's a hint for all of you electric universe type people who may understand a little bit about the cosmology. And here's another article on phys.org. This one by the National Radio Astronomy Observatory about oppositely rotating portions of gas and dust around a supermassive black hole. Now, the people that I typically talk to on the internet about cosmology will not be surprised by this one bit, just like I'm not surprised by it one bit anyway. This one looking at NGC 1068, and yeah, let me read a quote. And before I read the quote, let me just explain that cosmology, physics, astrophysics, etc. are being rewritten. Welcome to the Neo-Renaissance, folks. Welcome to the Neo-Renaissance. It's a delightful time to be alive as science is starting to advance in a way meaningful to people that understand the science. Counter-rotation is not an unusual phenomenon in space. We see it in galaxies, usually thousands of light years away from their galactic centers. Birkeland currents, explained co-author Jack Gallimore from Bucknell University in Lewisburg, Pennsylvania. The counter-rotation always results from the collision or interaction between two from a collision, eh? Okay. It could be from current flowing, but whatever. What makes this result remarkable is that we see it on a much smaller scale, tens of light years instead of thousands from the central black hole. The point is that all current flow involves Birkeland currents. And anyway, we linked this article below the video in the description box as well, so check that out. Read the article. You won't lose an IQ point, but you'll understand how, you may understand how and why astrophysics and cosmology are getting rewritten. And for that, we thank you. And here's another article, this one from the University of Southern Denmark, explaining how new understanding has come of the evolution of cosmic electromagnetic fields. Let me read a quote. Now, this flies right in the face of Big Bang cosmology, as Big Bang cosmology does not at all explain how these fields could exist. Recently, the researchers from the International Center for Theoretical Physics in Italy and southern Denmark have shown that due to Faraday's law of induction, the assumed evolution of electromagnetic fields after inflation, and we're talking about Big Bang inflation, is different than previously assumed if there are also strong primordial electric fields. Really? The problem is that magnetic fields generated during inflation have been believed to quickly be washed away by the subsequent ordinary expansion of the universe, making successful inflationary magnetogenesis a challenge. Let's reflect on that. Okay, that's enough reflection. Links to the article in the description below this video. And now I'd like to take the opportunity to say, Milky Way Galaxy team for the win. Thank goodness for the SMASH team, who we don't have to melt your head using our gigantism and massive electrical discharge powers. Are you an electromagnetic field emitter? Well, thanks, SMASH team, for being electromagnetic field emitters, and please stay tuned for one, count 'em, one slimly veiled section of bonus feature. As we refuse to have a set format, folks, the channel is constantly changing. Thanks, patrons. Please consider becoming our next patron. Patreon.com/smashomash. The real funding of this channel, as YouTube pays us precisely $0 for these videos. They figure out a way to throttle the content, demonetize, etc. on the regs. Let's zoom in at the northern portion. See if we see any magnetic field consolidation happening, and not really. Please leave a comment if you see a cycle 25 or 24 plage or sunspot that we've missed. I doubt we'll get any comments on that. Anyway, thanks for tuning in, everybody. Remember to stare at the sun. Use the proper instruments like a solar filter or perhaps the SDO. And when you're doing so, don't drink, and if you do drink, don't drive. And since it'll never be now again, may the solar wind be at your back and the atherosclerosis absent from your veins.